Okay, so on your specification, you should be able to use methods of differences to prove standard results. So by standard results, we're looking at the sum from r equals 1 to n of r, the sum of r squared, and the sum of r cubed. So I'm going to do this one. You will be led through them, so you won't actually have to remember a method as such for each one, and each time they'll come out slightly differently. So yeah, let's go for an example. So to start with, we're going to show that 2r plus 1 squared minus 2r minus 1 squared equals 8r. So we've got our difference in there. So this isn't particularly difficult actually. So you get 4r squared plus 4r plus 1, multiplying out those brackets, minus 4r squared minus 4r plus 1. And then that is equal to 4r squared go, 4r minus 4r is 8r, and 1 minus 1 is 0. And then we want to find the sum. From r equals 1 to n of 8r. So from this first section here, that sum is equal to the sum of the difference and then same methods we've been using all the way along. So the first term, so I'm plugging into here, is equal to 3 squared minus 1 squared. It makes sense just to leave that as 3 squared minus 1 squared because you'll probably pick up your patterns more easily than writing 9 minus 1. The second term is 5 squared minus 3 squared. You may want to do one more. Third term is 7 squared minus 5 squared, etc. So we're cancelling down like this. So I just really need the last term in there. So the nth term, 2n plus 1 squared minus 2n minus 1 squared. So cancel, cancel, cancel. That's going to go with that one there. And so the sum from r equals 1 to n of 8r is equal to minus 1 squared plus 2n plus 1 squared. This is minus 1 squared, so it's minus 1 plus 4n squared plus 4n plus 1. So they're cancelling off and you're left with 4n squared plus 4n. And then from there we can deduce that. I think I'll start a new board. Sum from r equals 1 to n of r is equal to a half n n plus 1. So we know that the sum from r equals 1 to n of 8r is equal to 4n squared plus 4n. So I can pull this 8 out, and then you can divide both sides by 8. So that gives me a half n squared plus a half n, and then obviously we can take a half n out as a factor. So you can do, a similar sort of thing to prove the results for r squared and r cubed, but you don't need to know the form to split it into. You'll get told that, so it's nothing really to worry about. You did prove these by induction as well, so there's not necessarily one way of proving something, but this just gives you another way of doing these as well.